Now, the last and oldest sections of the ice cores brought back from Antarctica are being melted for analysis.
The Antarctic is home to 60% of the planet's fresh water, so it's vital for sustaining future life on Earth.
Imagine waking up tomorrow and finding the world as you knew it has vanished. Every glacier gone, Antarctica and Greenland stripped bare, entire coastlines erased, billions displaced. What seems impossible overnight is actually happening in slow motion, and scientists warn the clock is ticking faster than anyone wants to admit. Tonight, we uncover the terrifying consequences of a planet without ice, from rising seas that redraw maps to hidden dangers lurking beneath the thaw. The question is not if it will happen, but how humanity will survive when it does. Could the Earth itself become unrecognizable in our lifetime? The Ice Age lie. Before we dive into the apocalyptic reshaping of civilization, let's address something that might actually surprise you. An ice-free Earth isn't unprecedented. We've been there before, and not that long ago in geological terms. Right now, we're technically still living in an ice age, specifically an interglacial period within that ice age, which sounds contradictory given our rising temperatures and record-breaking heat waves, but it's true. For the past 12,000 years, we've enjoyed relatively stable conditions with permanent ice at both poles. But rewind 130,000 years to the previous interglacial period, and things were dramatically different. Temperatures sat 2 degrees above pre-industrial levels, and sea levels stood 6 to 9 meters higher than today, primarily because the Greenland and West Antarctic ice sheets had largely melted away. But if you really want to see what an ice-free planet looks like, we need to go back even further to a time when dinosaurs ruled the Earth. 100 million years ago.
66 million years ago, dinosaurs ruled the Earth.
If you stood on Antarctica, you wouldn't see a single snowflake instead. You'd be surrounded by dense subtropical forests teeming with vegetation similar to what you'd find in modern New Zealand. Sea levels peaked at around 200 meters higher than today, the highest they've been in the last 540 million years. Under the bizarre conditions of 24-hour summer sunlight followed by 6 months of total winter darkness, plants thrived and dinosaurs roamed freely across the continent. 4-meter-long armored ankylosaurs, gigantic long-necked sauropods, and countless other species called this green Antarctic landscape home. This period, stretching from 100 to 66 million years ago, when the land dinosaurs went extinct, represents the last time we're certain Earth was completely ice-free. Today, that same Antarctic landscape is buried beneath an ice sheet larger than the combined area of the United States and Mexico, measuring an incredible 4.9 kilometers at its thickest point and holding approximately 60% of Earth's total freshwater. Greenland contributes another 8 to 10%, with the remainder distributed across mountain glaciers.
Glaciers have been shaping our world for millions of years.
Smaller ice caps, and the cryosphere, all the frozen components of our planet, including sea ice, snow cover, and vast permafrost regions. Now let's explore what happens if every single frozen molecule on Earth suddenly disappears. The drowning. The most immediate and visually obvious consequence would be the dramatic rise in global sea levels, and the scale is almost incomprehensible. During the age of dinosaurs, sea levels stood 66 meters above current levels, almost shoulder height with the Statue of Liberty. If all Earth's ice melted today, we'd see that exact scenario play out again. Antarctica alone holds enough frozen water to raise global sea levels by 58 meters, and when you factor in Greenland, mountain glaciers, and every other frozen reserve on the planet, you're looking at a 71-meter sea level rise that would brutally redraw every coastline on Earth. Nearly every major coastal city would be plunged beneath the waves, erasing population centers that house billions of people. On the United States West Coast, Los Angeles would be completely underwater, and San Francisco would transform into its own isolated island. The East Coast faces equally devastating losses. The entire state of Florida vanishes. New York City disappears beneath the Atlantic, and even Washington, D.C. becomes submerged. Europe would lose the Netherlands entirely, all of Denmark, and nearly half of Belgium would be claimed by the sea. The United Kingdom, where I currently live, would fragment into an archipelago, and London, the city I call home, would cease to exist. Further east, the Black and Caspian Seas would merge for the first time in 5.5 million years, suddenly giving Kazakhstan, Uzbekistan, Turkmenistan, and Azerbaijan direct ocean access. Major Asian cities, including Beijing, Shanghai, Seoul, and Tokyo, would face completely transformed waterfront landscapes, and the entire nation of Bangladesh, home to 173 million people, would be wiped off the map in an instant. Only Africa would escape relatively unscathed by comparison, although Cairo and Alexandria in Egypt would become casualties, along with significant portions of Mauritania on the west coast. But catastrophic sea level rise is merely the beginning of the havoc this ice melt would unleash, because something arguably even more disturbing would simultaneously occur: Earth's wobble. The displacement of billions of people and the destruction of coastal infrastructure is horrifying from a human perspective, but the planet itself would experience something even more fundamentally dramatic. The actual movement of Earth would be altered. When massive quantities of land ice melt, the water's mass shifts from the poles toward the equatorial ocean, essentially redistributing weight away from Earth's rotational axis. This increases the planet's moment of inertia, its resistance to rotational acceleration, causing Earth to slow down, exactly like an ice skater extending their arms away from their torso to decelerate a spin. If the total mass of water stored in ice sheets and glaciers, more than 30 million gigatons, were suddenly redistributed across the oceans, the planet would slow measurably. Calculations show that melting Greenland's ice sheet alone would increase the length of each day by approximately 2 milliseconds, and since Greenland represents only about 10% of Earth's total land ice, with most reserves concentrated at high latitudes, we can extrapolate that complete ice melt would lengthen each day by at least several milliseconds. That might sound trivially small in our fast-paced modern world, but it's comparable to how much the moon slows Earth's rotation over an entire century through tidal friction.
Tides, the up and down movement of the oceans, are a result of three main forces: the influence of the moon, of the sun, and the rotation of the Earth.
While almost imperceptible to human experience, this change would send technologies dependent on precise timekeeping into complete chaos. GPS systems, satellite networks, commercial aviation, and space travel would all require immediate recalibration. But rotational speed isn't the only change we'd face. These massive shifts in planetary mass distribution cause Earth to wobble, moving the spin axis slightly away from the imaginary line connecting the geographic north and south poles in a process called polar motion. Even a slight shift in axial tilt could trigger cascading changes to climate patterns, seasonal cycles, weather systems, and ocean currents, with effects ranging from subtle to absolutely catastrophic depending on the degree and speed of the shift. Northern latitudes might experience longer, more intense summers, while southern regions could face increasingly harsh winters. Major ocean currents like the Gulf Stream or the Atlantic meridional overturning circulation, both driven partially by Earth's rotation, could veer dramatically off their established courses. A slight tilt might completely disrupt the jet stream, leading to erratic storm patterns. Imagine hurricanes striking completely unexpected regions or prolonged droughts, devastating areas that previously enjoyed stable rainfall. These seemingly subtle planetary adjustments would create massive ripple effects for anyone left surviving on Earth's transformed surface. And the changes don't stop there. The land rises. Without the immense weight of massive ice sheets pressing down on Greenland and Antarctica, the land beneath would begin a slow but dramatic comeback in a geological process known as glacial isostatic adjustment. Imagine Earth's crust functioning like a memory foam mattress under a heavy weighted blanket. The gigaton weight of ice presses the crust downward, causing the edges to bulge outward. Ice acts over thousands of years, transforming solid crust into something behaving more like extremely thick honey, viscous and slowly flowing. When you remove that ice weight, the previously depressed regions bounce back upward while the bulging edges sink down, exactly like your memory foam bed reshaping itself after you get up, except this occurs on a planetary scale. Under normal conditions, this process takes millennia to complete, but in our hypothetical instantaneous ice melt scenario, who knows what timeline we're looking at. Remarkably, this exact process is actively happening right now as you watch this video. In Scandinavia, people noticed their shorelines shifting. Centuries ago, the ancient port of Östhammar in Sweden became completely landlocked by 1491, forcing the entire town to relocate. During the 1700s, scientists carved precise sea level marks into rocks and meticulously tracked the changes. discovering that in the Gulf of Bothnia, sea levels were dropping 1.4 centimeters annually. But measurements varied at different geographic points, proving conclusively that the land itself was rising unevenly, rather than ocean levels falling uniformly. The explanation lies 21,000 years in the past during the last glacial maximum, when enormous ice sheets blanketed northern Europe and North America. As those sheets gradually melted, the compressed land began slowly rebounding upward, and Scandinavia continues rising today. Returning to our complete ice melt scenario, the underlying continents previously covered by ice would undergo post-glacial rebound on an absolutely enormous scale. Precisely how much the land would deform and the resulting impact on local sea levels remains uncertain, because these calculations require much deeper understanding of the mantle composition beneath Greenland and Antarctica, as well as more exact dating of when ice sheets first covered these landmasses. What we definitively know is that sea levels would continue changing for extended periods long after all the meltwater has reached the oceans. In the shorter term, the immense sudden ice loss would instantly reconfigure Earth's gravitational field, potentially amplifying sea level rise in tropical regions and making a 66-meter rise even more catastrophic for equatorial populations. No matter how you analyze it, the news isn't good. But believe it or not, there are some people who might actually disagree because they see opportunity in catastrophe, hidden worlds exposed. In a total glacial melt scenario, uncovering Antarctica and Greenland would expose hidden worlds to the surface for the first time in millions of years, but we actually already know what these landscapes might look like. Over the past century, scientists have been systematically mapping the bedrock beneath ice sheets using satellite surveys, advanced radar, seismic reflection studies, and gravity measurements. They've discovered that Antarctica features dramatic topography, sharp mountain ranges, and plunging valleys carved by ancient geological forces. It's home to Earth's deepest land canyon, reaching depths of 3.5 kilometers below sea level. And three-dimensional mapping clearly shows the geological distinction between East and West Antarctica. The East is generally more elevated terrain, while the West consists of a collection of mountainous islands. These are landscapes originally carved by rivers, and scientists have identified 675 recorded subglacial lakes trapped beneath the ice. The largest, Lake Vostok, stretches 250 kilometers long and sits approximately 4 kilometers underneath the ice sheet. There are also hundreds of volcanoes. 138 have been identified in West Antarctica alone, creating a hidden volcanic landscape completely invisible from the surface. Greenland has been mapped far less extensively by comparison, but we know it features similar mountain systems and contains at least 60 relatively small subglacial lakes. The critical question becomes, would an exposed Greenland and Antarctica remain barren wastelands, or could humans actually find ways to successfully inhabit these newly revealed continents? While we can't predict with certainty, what we definitively know is that both likely contain resources humanity desperately needs, buried deep beneath the surface rare earth minerals that drive modern technology. Commercial mining in Antarctica was banned under the Antarctic Treaty, and as a result, no extensive mineral surveys have been conducted, but the continent is believed to be extraordinarily rich in valuable resources, including vast coal and oil deposits. Similarly, a 2023 geological survey revealed that Greenland contains 25 of the 34 minerals classified as critical raw materials by the European Commission, making it the 8th largest known reserve globally. Some political analysts argue this explains why President Donald Trump has repeatedly attempted to purchase Greenland from Denmark on multiple occasions. In a world stripped of ice, could international treaties be torn up and a geopolitical scramble commence to claim and exploit these resources? Based on human history so far, you absolutely wouldn't bet against it. The new Cold War. In recent years, the Arctic Circle has already become the epicenter of intensifying geopolitical conflict, and what's happening there right now provides a chilling preview of what could occur if Greenland and Antarctica become accessible. As Arctic ice caps tragically melt away, major powers, including the United States, Russia, and China, are aggressively rushing to assert territorial claims over the region's previously inaccessible territory. The Arctic occupies a strategically critical position between North America and Eurasia, making it an enormously powerful location from which to project military strength. and the region houses absolutely vast natural resources. A U.S. Geological Survey estimates the Arctic contains 48 billion cubic meters of natural gas and various other fuel reserves, equal to the entirety of Russia's known oil reserves.
Russia, a leading oil and gas exporter, has used more than 50% of its known oil reserves and might need to attract enormous investment.
And 3 times the amount contained within the United States. The Chinese government has explicitly dubbed the Arctic region their Polar Silk Road, clearly signaling the trade routes and resource extraction they intend to pursue following acquisition of these natural resources. The fascinating part is that China has zero Arctic border, instead creatively describing themselves as a near-Arctic state, despite the fact that their northernmost regional capital, Harbin, sits on roughly the same latitude as Venice, Italy nowhere close to the Arctic Circle. As recently as 2024, the last remaining piece of privately owned land in the Arctic archipelago of Svalbard was listed for sale at $324 million, dramatically marketed as the gates to the Arctic. The Norwegian government ultimately had to intervene and forcibly cancel the sale to prevent acquisition by China, and this wasn't the first time such intervention proved necessary. Chinese attempts to purchase strategic seaports in Norway and Sweden, and even an airport in Greenland, have all been blocked by governments recognizing the geopolitical implications. But it's not just nation-states seeking to benefit from our thawing planet niche money-making schemes exploiting glacial melt have emerged everywhere. Off the coast of Svalbard, entrepreneur Jamal Qureshi literally collects blocks of Norwegian glacier ice from the ocean and bottles it as premium luxury water. The ice is expensive and difficult to collect and purify, with production limited to just 13,000 bottles annually, currently selling for $100 per bottle. In Russia's Yakutia region, melting permafrost is revealing 11,000-year-old mammoth remains, and demand for this ethical ivory has exploded in China, where a single tusk can fetch up to $100,000 on the black market.
Illegal traders. There is a legal market.
Japan's ivory industry.
The people extracting these fossilized remains are known as tuskers, and they carry powerful firefighter pumps on their backs, using high-pressure water to carve enormous 180-foot tunnels under frozen ground to extract the bones. The race for Arctic resources is already in full swing, clearly demonstrating that if our ice-free world scenario ever materializes, it would trigger fascinating and potentially dangerous geopolitics if Antarctica and Greenland face similar territorial scrambles. The timeline of terror. This entire scenario is purely theoretical, a ridiculous hypothetical that could never actually happen in reality. Right? Wrong. The short answer is, it won't happen overnight, but we're already on the path, and the timeline is more terrifying than you think. Significant ice loss has happened before 130,000 years ago during the last interglacial period. Sea levels stood 6 to 9 meters higher than today because Greenland and West Antarctic ice sheets had largely melted. The kicker? Global temperatures back then were only 2 degrees above pre-industrial levels, and we're already at 1.1 degrees higher right now. If emissions continue at current levels, the Intergovernmental Panel on Climate Change predicts temperatures will hit between 3.3 and 5.7 degrees Celsius by 2100. Here's what makes your blood run cold. The most recent IPCC report explicitly stated that sustaining just 2 to 3 degrees of warming could trigger almost complete and irreversible loss of Greenland and West Antarctic ice sheets, causing at least 13 meters of sea level rise. Other research puts a date on complete melt of one major ice sheet, the year 3000, producing a minimum of 7 meters in global sea level rise. 1,000 years sounds distant, but in climate terms, that's lightning fast. We're technically still in an ice age that's lasted 12,000 years with relatively stable conditions, and now we're talking about undoing millions of years of ice accumulation in just a millennium. The East Antarctic ice sheet hasn't been ice-free for 66 million years.
The East Antarctic ice sheet, the world's biggest, was less at risk from climate change than West Antarctica due to its extremely cold temperatures, which can reach -40 Celsius.
But under rapid warming, all bets are off. The problem is our models remain incomplete because we don't fully understand how ice sheets interact with warming oceans, changing atmospheric conditions, and rebounding bedrock. What we do know is terrifying positive feedback loops accelerate everything. As ice melts, darker surfaces absorb more heat, which melts more ice. Thawing permafrost releases greenhouse gases, which causes more warming, which thaws more permafrost. Each level of melt triggers increasingly dramatic consequences in a runaway chain reaction. The timeline isn't some distant future problem, it's unfolding right now. And every year we delay action, we move closer to the point of no return where even our best efforts can't stop what we've set in motion. We've seen a world stripped of ice, coastlines erased, and billions of lives on the edge. And yet, despite this looming catastrophe, the window to act still exists. Every choice we make today, every policy, every innovation, every step toward sustainability determines whether future generations inherit a familiar Earth or a planet unrecognizable. The question isn't whether we understand what's coming, it's whether we have the courage and will to stop it before it's too late. When the ice finally disappears, what kind of world will we have left for those who come after us?